Good afternoon. Hope you can all hear me. This is very strange talking to a camera. Well, welcome along to DDD 2020 virtual. Hopefully I met some of you in person previously. Actually at Reading, so which is not far from me here. But no, it's great that we could have this online given the current circumstances, and hopefully it's been a good event for you. I've been seeing some interesting things, and hopefully this will be interesting for you too. Just some quick words on points of note. So there's a code of conduct, as you'd expect. I think most of these points are fairly self-explanatory. There's a link there to the full code of conduct. But I think in summary, be nice. In terms of being nice, you could also be nice to the National Computer Museum, who we're supporting this year, which I think is great. Go and give them some money. Yeah, worthy cause, I think. A really interesting place to visit too. And also nice of the sponsors to help us out, particularly this year. You know, Black Marble have done a lot of the organisation, supplied a lot of volunteers. You know, Microsoft are always a big help, lots of giveaways from them. And you know, Sage, Grey Matter, NDC London, which is a great conference happening in January. Landmark, IO, Recruiters Associates, and University of Hull. Thank you very much. You can always thank the sponsors on Twitter. If you do put some tweets out there, use the hashtag DDD2020. Let's make some noise about DDD 2020, because people can still come along. Great thing about being virtual, they can just drop in. So, just a quick mention of this. So, when I submitted a couple of talks to the conference, and OhWASP App HUD WCF was the one that was published on the agenda, but that was only a lightning talk, so I wanted to give you better value for money, and actually include the other one as well, which is Fancy Bears Are Not Your Problem. So I'm going to do a medley of both of those things, so you get 2 for 1. So let's start with the first one, which is Fancy Bears Are Not Your Problem. So I'll tell you what, here's me. Hello. This is, as I say, Fancy Bears, not your problem. Thing to point out now is that there's links to my blog at the end of the slides with all the interesting resources. So you don't need to necessarily take notes or review the video. Hopefully they should all be on there. I am Robin Minto. I work for a company called Buybox. We're a supply chain management company and technology company in the UK, but we operate globally. Lots of customers you might have heard of, lots of customers you won't have heard of, even if you haven't, and you probably haven't heard of us either. So I'm a technical architect, software developer, working on web, mobile, server-side applications. We've got a distributed team of software developers. Most of them are in the UK, but a few of them are based around the world. So yeah, that's Buybox. I won't talk much about this, but it's an interesting little point. I mean, my interest in security goes back a long way, kind of as long as these things have been around. This is a floppy disk, and they're pretty old, as am I. So that's how far my interest goes back. There's a story about this, which I won't tell you now just for brevity, but yeah, pretty old. So why do we care about security? Kind of the first question to think about, I think. For me, there's a couple of things. People entrust their data to us. We've got a duty of care to look after it. It could be company data, it could be personal data. I mean, really, that all comes down to money. It's all about the money. This could be the cost of cleaning up a breach, could be reputation damage. You know, it could be headlines like this that you see in the newspapers. Might be direct theft or blackmail, people trying to get Bitcoin out of you. It could be fines. you're probably familiar with GDPR by now. You need to avoid those fines, which can be significant. Now, I don't know if anyone has actually heard of Fancy Bears. Maybe you've heard of Stone Panda, Charming Kitten. These are all APT hacking groups. Now, what are APT hacking groups? Well, they're advanced persistent threat groups. So these are advanced nation-state organised crime groups who take part in long-term hacking operations. So they're well funded. They can generally get through most security perimeters, and they're persistent both in their attacking methods and how long they stay around in your network. And I wanted to talk a bit about Fancy Bears specifically. I'll talk a little bit more about the others too. And they've been involved in various operations since 2014. They came up with the Sophacy malware. Sophacy is another name for Fancy Bears. I'll come on to naming soon. They've used zero-day exploits for Windows, Flash. Attacks on the German government, French television, international banks, the White House, NATO. But they kind of gained mainstream attention in 2016 when they got involved with the World Anti-Doping Agency. This was around the time of the Rio Olympics, and the World Anti-Doping Agency, who will look after, they try and prevent doping in sport across the world. They recommended that Russian athletes be barred from participating in the Rio Olympics because of doping issues. And Fancy Bears basically broke into WADA and released a lot of medical information onto the internet. And this was in retaliation for that recommendation against Russia. This affected athletes like Mo Farah, who you'll be familiar with. I don't know how many people are familiar with Bradley Wiggins, cyclist. But these athletes had applied for what are called therapeutic use exemptions, TUEs. They've got a medical condition and they see a doctor, and the doctor suggests a treatment, and that might be a substance which is seen as performance enhancing, so it's banned by the World Anti-Doping Agency. But you can use that substance with a therapeutic use exemption, and these are the records that WADA were holding that were then released by Fancy Bears. I mean, subsequently the website was taken down, but that data is then out there. Now, APT groups have different names depending on who you ask. So Fancy Bears has got a variety of different names. These will be different government organisations and security companies who need to identify and name the groups, and they don't necessarily come to the same name, but often one of them catches on. So various organisations look at the malware and the operations of the groups and try and attribute efforts into hacking to different groups. I mean, it's hard, but there's generally consensus that around the origins of the Fancy Bear group. So these organisations, the Foreign and Commonwealth Office in the UK. I don't know if you recognise this guy. This is Robert Mueller, former FBI director. He was appointed special counsel to oversee investigation into Russian interference in the 2016 US presidential election, and he indicted a number of the Fancy Bears team for hacking into the Democratic National Committee and leaking information from them, not to mention some of the other operations. But then there's security companies like Mandiant and Threat Connect and SecureWorks who also name these groups in different ways. But amongst all these organisations, there's general consensus that Fancy Bears leads back to Russia. And here's the boss, of course. I mean, that's just quite a collection of pictures. Not much more to say about that. I mean, specifically, fancy bears are linked to the GRU, the Foreign Military Intelligence Agency of the General Staff of the Armed Forces of the Russian Federation. I mean, one of the techniques they use to identify this group is that the malware was sort of compiled in working hours, Russian working hours, and it's things like that they use. Oh, not to be confused with Gru from the Minion movies, of course. And every country have got their own advanced persistent threat group, it would seem. So fancy bears, Russia; stone panda, associated with China; charming kitten with Iran, and every country seems to have their own group. And if I go over to a web browser, I can show you this Google Doc, which basically tries to list some of the groups that we're talking about. So here you can see common names, Sophacy, fancy bear is one of their names. You can see various bear groups all over the place, but I mean, there's a real variety of different names in here. If I flick over to China, you'll see that they're all panda based. Iran is a kitten theme often. I mean, CrowdStrike are responsible for some of the pandery ones. I mean, one of the interesting things to point out is if we go to the NATO tab, this is the equation group, which are a group widely believed to be in the UK, but I like that their name is Housefly. Seemed appropriate. Panda for China, bears for Russia, kittens for Iran, and insects for the UK. Seemed fitting, perhaps. Anyway, so I want to talk a bit more about the human brain, and how these groups affect our brain, and how stories around these groups affect our brain. You know, the brain is amazing. We take it for granted, I think, but it's an incredible thing. Now, there's a primitive part of the brain that deals with risk. That's the amygdala. And there's a more advanced, more recent part of the brain which we use for analysis, which is the neocortex. And these two parts of the brain are operating in parallel, but one of them is faster than the other. The amygdala gives us a fast reaction and response to threat. The neocortex, we then get to analyze those threats later. This is a little video just to demonstrate that point. So a guy in a baseball net throws the ball out, and it comes back straight at his head, and he reacts well enough to catch it before it hits him in the face. But you don't necessarily have to be a highly trained athlete to react in this kind of way. So, you know, you're watching a baseball game in the US and a ball flies into the crowd. You're on your phone, but you just reach up and catch it. That's what's happened here. I don't have any video from this guy, but you know, he's just sitting there and reaches up with his reactions, his amygdala at work, catching that baseball. And the reason I started looking at baseball in this context was this quote from Daniel Gilbert, who's a psychology professor at Harvard. And to me, this sums up. It's a great summary of the amygdala and neocortex and the comparison between them. So the amygdala is the application that allows us to respond to visible baseballs. It's ancient and reliable, but the add-on utility that allows us to respond to threats that loom in an unseen future is still in beta testing. and that's the neocortex. For me, that really sums up those two parts of the brain. And the way we respond to threats, affected by these two parts of the brain, is what I wanted to delve into. So when we see a threat like this, this big great white shark, the brain sees it as a threat immediately. But actually, in reality, you're more likely to be killed by a dog than by a shark. Okay, so that's a threatening dog, but these are the ones you have to watch out for. So we exaggerate and we downplay different threats based on our brain's reaction. So we exaggerate the spectacular and we downplay the pedestrian. So in terms of the shark and the dog, two good examples. We also exaggerate rare threats and we downplay common ones. So as I've been thinking about this talk again today, I've been thinking about coronavirus. So coronavirus is a global pandemic is rare, but a winter flu is fairly common. So we're much more fearful of the pandemic than the flu, and some of that is rightly so. Threats that are talked about, we exaggerate. Threats that are downplayed, threats that are not discussed, we downplay. And threats that are immediate, again, exaggerated. Long-term, downplayed. New and unfamiliar, exaggerated. Familiar, downplayed. And I thought about the fact that the whole world rushed out to buy toilet paper when coronavirus was new and unfamiliar. But actually, when it got more familiar, people wanted just to go out to the pub. And we exaggerate things that are uncertain, and we downplay things that are well understood. So what's this got to do with security? Well, media organizations will play on our emotions because they understand this about the brain. They realize that if we see these threats, we're instantly going to respond to them. So they have clickbait headlines to draw us in. This isn't a real one. I made this one up. But you can imagine 10 things that BuzzFeed want you to read about that will amaze you, etc., etc. Some of the headlines are real. APT group news is spectacular and it is unfamiliar, so it is newsworthy. It gets us to buy papers and it gets us to click links. So some of these are real headlines from the BBC. Bruce Snyder has an interesting thing to say about this. He's a very well-known cryptographer and security guru. Talks a lot about, writes an extensive blog on security, and also they talked about the psychology around it. But he says if it's in the news, don't worry about it. Again, thinking about coronavirus, it's sort of fairly it's sort of slightly different scenario for coronavirus, because obviously it is in the news and we do want to care about it. But this is more about those sort of sharp, instantaneous events that worry us, when they're in the news. Maybe plane crashes, obviously horrible events, but they are fairly infrequent, and you're probably more likely to die in the taxi on the way to the airport than you are in a plane crash. It's that kind of sentiment. It's realizing what the brain is doing. Now, obviously, there are some headlines that we do want to pay attention to. We can learn from this sort of thing, but we don't want to make it our entire focus. So here is an APT group. Wannacry was attributed to North Korea, but there's probably a lesson here, which is patch your stuff. It was, this was back in May 2017. The Eternal Blue exploit was stolen from one of the intelligence organizations in the US, and then it was they patched it in March, but months later Wannacry hit because people weren't patching. So I've talked a bit about how our brain thinks about risks, and so how do we combat that that amygdala response and focus more on the analytics and deal with the analysis of that risk? So one place to start, a simple first step, is evil user stories. So I hope you're all familiar with the user stories in the context of your development, but evil user stories are a great way of starting that conversation about threats into your system. So as a hacker, I want to break into another user's account so I can steal their credit card number. Obviously, you're not going to go off and implement that, but it starts that conversation. You can then think about the threats, understand how you're going to protect your system against that kind of problem. And you might have personas in the same way that you've got for your user stories. So as a disgruntled employee, I want to delete all the stock, so the shop will appear to be out of stock and I'll be unable to sell anything. And then you can use sort of more structured techniques. So Microsoft have threat modeling as part of their security development lifecycle. The process and techniques are useful even if we don't want this level of formality. So let's talk about this a little bit more. So what you're going to do is you're going to define your security requirements. You're going to diagram your system or your components and your data flows. You then identify threats to those components. You mitigate those threats, and then you validate that you've mitigated correctly, and you keep doing that until you're satisfied that you've mitigated the risks to a sufficient level for your threat. And there are tools around that. In fact, this is the Microsoft threat modeling tool. This is an example that I drew up to illustrate. So you model your system in here, draw your diagram, your components and your data flow, and it allows you to document threats and mitigations. So actually, if I go over to, I'm going to go over to this browser window. So this is a report which comes out of the tool. You see my model, and there's lots of detail in here about potential threats to your system, and then explanation on how you might mitigate. Lots and lots of detail in there, and that's a free tool from Microsoft that you can use. On the identification step, there's another interesting model out of Microsoft that's worth looking at in a bit more detail. So this is the Stride framework. So Stride stands for spoofing. This is impersonating someone or something. This might come from the lack of sufficient credentials. So in your authentication, you might then farm your authentication out to Azure Active Directory or Auth0 or some other provider. Stolen credentials might fit into this category. Again, you might mitigate that with multi-factor authentication, and there's various other things that you might consider in this section. T is for tampering, modifying data or code. You can imagine threats like open Wi-Fi, easily mitigated with HTTPS in general, or it might be you're handling documents and you need to make sure that they're tamper-proof, so you add digital signatures. Repudiation. So I didn't change that data record, said somebody. Well, okay, so you have some secure logging and auditing in there in your system that could deal with that, or you have digital signatures, so people are signing. So when they're claiming to not have performed an action, you've got the evidence there to show that they did. Eyes information disclosure. So this is potentially, this might be data at rest, which you could deal with encryption. Data in transit, similar to the Open Wi-Fi problem. Again, HTTPS might help you with that. Direct object reference problems, so where you look at a URL and it's got an ID in it, and you just change the ID and you've suddenly got somebody else's data. Well, you've got an authorization problem there that you might mitigate, things like that. Denial of service, so this might cause problems in your system, denying service, degrading service to users. So you might have some level of filtering in there so that large requests are thrown away, or if you get floods of requests, you've got quotas, or DDoS protection from Cloudflare or an API gateway or similar. Lastly, elevation of privilege, gaining capabilities without the authorization. So I'm a basic user, but can I get up to admin? And generally this will come down to access control lists and role membership, input validation, those sort of things. And by the end of this process, you end up with an idea of the threats facing each of the components of your system. Just on some of the other steps of this process, if we look at mitigation and validation, there are a few categories of mitigation that you might want to consider. So you might redesign to eliminate the vulnerability. So that direct object reference issue I talked about, instead of a number for the ID, you might have a GUID, so you can't just change it. Not your only mitigation, but that might be one of them. You might have standard mitigations, so data in transit, use HTTPS as a standard mitigation. It's fairly straightforward. You might invent your own new mitigation. Example might be you decide to design your own custom password encryption. Generally not a good idea, so think carefully about inventing your own things, but that's an example. And then you accept the vulnerability potentially, so you might say, actually at our level we're not expecting fancy bears to hack into our system, so we might accept this vulnerability. And then in terms of validation, here's an example of our agile software process, which is Scrum or Kanban or whatever it might be. So you're developing your code, and then eventually you release it, and then you deploy it, and then you operate it. Now, where do you validate in this process? Now, often we'll throw in a pen test at the end, and we can certainly do that, get some expertise in, but actually when you're QAing, you're doing that around this process. It's integrated into it. It's not something that happens at the end, and security should be there as well. So it's part of that planning process, part of that design process that we talked about with Stride. And there are also some tools to help to find some of those issues for you. Things like Zap from OhWASP, which I'll talk a bit more about later. BDD security perhaps, or if you want to pay some money, you might have Veracode or NetSparker in there in your process, doing some static analysis on your code or some dynamic scanning. All good options. And then we don't want to forget about the basics like passwords. So they're a big part of the problem. 81% of hacking related breaches leverage stolen or weak passwords. And then there are really good resources like OhWASP that can really help with these issues. Lots of the OhWASP top 10 for web apps, APIs, mobile apps, cheat sheets, other tools like Zap, which I'll come on to. Really great source of things. So the media will continue to tell us about really exciting hacking stories just for our entertainment, and in some of them we'll learn some lessons, but my key point here is that it shouldn't be the focus of all of our efforts, and there are ways to stop our brain from jumping into that fight or flight mode, thinking about these issues. So in this case, the GRU didn't do a great job. Yeah, okay, good work, boys. But you know, there's probably things that we can learn from the fancy bears. But you know, now we understand a bit more about how the brain reacts to these news events and how we can analyze a bit better. Hopefully we won't be afraid of the fancy bears, because I think we've probably got more important things to worry about. I mentioned there's some links to the resources on my blog. Now, if there are any questions around this, I'll take them at the end in about a quarter of an hour. Now, I did promise 2 for 1, so the next part of this talk is about OhWASP Zap, which is one of the tools that we can use as part of our development process early on. So this is probably after the design phase when we're actually working on our app, but it's a useful tool that can really help with our application security. So I realised that this is a bit of a jumble of letters, and that was sort of the part of the point of my title. But let's unscramble it. So if you haven't heard of OhWASP, it's the Open Web Application Security Project. It's a charity, local user groups all over the world that you can join, and members create projects and articles and documentation and standards for web security. One of those tools is Zap, which is the Z-Attack proxy. One of the flagship projects. It's a scanner intercepting proxy for security testing. It allows you to catch security issues in your code as you're developing. You can use it as part of your build pipeline or for penetration testing. And it's free and open source, which is cool. Cross-platform, written in Java, runs locally or in Docker, etc. Actively developed, 75 contributors on GitHub at least. Now the HUD is head-up display. I don't know if you're familiar with these, but you might have seen them in, you see them in aircraft, you see them in cars nowadays, and computer games like Halo. It's basically presenting information in your field of vision. WTF, I think you probably know that one. I also like to talk a bit about pushing left. So there's these bugs early on in our system, and the earlier they're fixed, I should say, the cheaper they are to resolve. So as we go through our development life cycle, the bugs are more and more expensive to fix. So pushing left is resolving those bugs earlier in the development process. So rather than waiting for that pen test at the end to find them, we find them as we're developing. And that's where Zap can help. So I mentioned it's a scanner and it's an intercepting proxy. So let's talk a bit about what that means. So in scanning mode, you've got your web app and you've got Zap running on your machine, possibly, and it will send requests to your web app, and it will analyze the requests and the responses and look for vulnerabilities in your app. But it's preferable to use it as a proxy. Now in that mode, you take your web browser and you explore your app using Zap as a proxy. All the traffic goes through Zap, and it can again look at those requests and responses, but you're navigating your website, so you're telling it how to navigate your website and where the interesting things are. So Zap's intercepting and analyzing that traffic. How do you get started? Go to the home page on ohwasp.org, download the installer, or if you're more like me, you'll use the package manager like Chocolatey, Homebrew on Mac, or Docker, as I mentioned. Again, there's links on my blog at robinminto.com/talk/zaphud. But let's have a look at Zap in practice. So I have got Zap up and running. I'm going to create a new session in here. So I'm going to say new session, please. Thank you very much. Obviously quite a lot going on here, but there is a quick start tab. And there are tutorials on the sort of 10-minute tutorials on the Zap website, and the HUD has also got a walkthrough sort of training platform built into it, which is quite cool. So what I've done there is I've gone to Manual Explore. Here's my website that I want to look at, which I'll drag up here. This is Bob's Discount Diamonds. So this is a deliberately vulnerable website that I built for testing purposes. So I can send messages to the website. I can look at different products. I can go into the admin menu, or I can search, things like that. Now what Zap will do for me if I use the HUD, so I'm going to go to that website, I'm going to launch the browser with the HUD enabled, and it's going to pop up over here, drag that there. Okay. So the HUD is here. It's these elements that it's inserted into the HTML for me. So if I can zoom in on that, some bit down the bottom, history and WebSockets, more on the right. And this is basically giving you that information front and center as you're exercising your app. So first thing I'm going to do is add my website to scope. So I'm saying that this is something I'm interested in testing. I can send a message to the website. I can see that in the history. Here's my request and response. I can sort of explore the website, and as I'm doing so, Zap is scanning all the time, looking at all the requests, and telling me about problems as we go. I can see already that I've got some page level alerts, some misconfiguration here, information disclosure, or got some, again, site level configuration issues, the same, some headers missing perhaps. I can break into requests. So if I turn break mode on and then put in my message, it then gives me the option to then come along and change it. And my message has been changed. Now I can tell Zap to basically spider my application, look at all the issues. So let's do that. Start on there. That'll be fairly quick because it's a small app. I'm also going to start an active scan, which is where it's going to actually vary the requests that it makes to the website based on that spidering. It knows where the pages are. Also, from my exploration, it will do some active scanning of the pages, and that will kick off in the background. But I can see that there are some issues happening. Some more issues might pop up as it's going through. There's one. It's got a cross-site scripting issue, so I can look at that, and I can see where it happened, how it happened, some information about the problem, how it was exploited, and what I might do to fix it, with some links to OhWASP and other references there. So that's pretty cool. I can show hidden fields, which is here. So here's a hidden field in the app. I might go in and change that perhaps. Who knows what that might do. I can also show comments. So here's a comment. What does that say? Okay, got a problem here. Maybe I should look at that. And then once I've done that, I can go and look at a report for the whole thing, and it will tell me all of the issues that it's found in terms of priority. It's got a SQL injection problem there. That's how it was exploited. Again, this is the stuff that was visible in the browser, but now I've got a report that I can send off to my team. Loads of information in there. Yeah, so here are the site level alerts that it found. There's that SQL injection. Headers missing and the like. So that is a whistle-stop tour of Zap and the HUD. The resources are on my website, as I mentioned. Download Zap, give the HUD a go. It's really interesting. Look at the other resources from OhWASP. Make sure you're testing early. Have a look at some of the other interesting security talks at DDD today. Certainly a few on which I'm really excited about. Let me know how you get on. Enjoy the other talks. And I think we've got a couple of minutes for questions, if there are any. Let's have a look at the panel. No questions. Good. I've achieved enlightenment. Hit me up on Twitter if you got anything to add later on, if you think of anything. Happy to answer questions there. Yeah, thanks very much for coming to this talk, because obviously there's a lot of choice. And thanks for coming to DDD, and have a great rest of the day.